Coming speaker is Mr. Ivan Ma. So Ivan is the MySQL user group lead in Hong Kong. He has over 20 years of experience in enterprise system infrastructure and software technologies. So he has certifications in MySQL, Java, Solaris, and Sybase. And he's now the master principal solution engineer in Oracle MySQL team. He's responsible for pre-sales, community activities, and product promotions. So you can see Ivan is probably the most qualified person to share with you the technology in MySQL. So today, Ivan will talk about the topic exploration of MySQL operator for Kubernetes in Python. MySQL operator is an operator written using Python. So if you're interested in Kubernetes and containerized solution, then this talk is definitely for you. So let's give a warm welcome to Ivan. Thank you.
Hello, it's good. Still morning. Yeah, it's good to speak in here. And Python and PyCon here. So basically, as mentioned, Scott, yeah, we'll go over the container deployment where the MySQL or your applications is likely, going over the trend. People wants to be more flexible and deploying cloud and more like the layer which can be actually independent to the vendors, to the platform, and so you have the flexibilities to move around. So how is that actually we can leverage, kind of like KOPF framework, to build the operator, and how this actually apply to the MySQL operator, and then we will see it in actions, in the few minutes. So that's why we try to explore how operator can be created. So to me, my name is Ivan Ma. So as mentioned, I'm actually in Oracle, and yeah, at Oracle, I'm the pre-sales and technical people, and have been actually, yeah, doing a lot of consultings and yeah, with Java projects, speaking in in the past, Java 1 and things, and also the working with the Asia Pacific, like Sybase, and here's today's SAP. And now at Oracle. And the topic, operator, Kubernetes, container, all these buzzwords. Do you know what that is? Operators, containers, do you use it? Anyone who has been actually using container? Wow, quite a lot. Are you using manifests, YAML files? Who is using Helm chart? So a lot. What about operators? Do you create your own operator CLD? Yes. Who is using Go for the operator programming? Who is using Python for the operator? No one. Anyone who has been exposed to KOPF? No. So I hope today the sections is good for us to be here. To start with, I will start with the KOPF. How operators can be written. And then you can actually play around. And then we explore what next with the MySQL operator, how this is being written, and how we can leverage and use it, and why we do this. So basically, as you can see, as a very quick start, what is Kubernetes? It's the container. It's actually quite flexible and really, we want the deployments to be so easy, and that's why there are so many resources. A port, a container, and some sort of the services and deployment, stable set, status. All this replica set and all this, they are kind of, in the Kubernetes world, we call those what? Resources, right? API resource. Can we define our own? Like what today? We have the PyCon resource, Hong Kong. Can we define this kind of keywords? PyCon, or what we have here? We can create kind of the CLD. And here, when we create kind of the resources, we need some sort of framework, okay? Maybe, hopefully that will be quite easy for us to leverage, okay? That kind of frameworks to easily to build, okay? When we create kind of resources, then we can extend those, okay, to do some other things. When we create PyCon, something happened to generate some more peoples or some more like the venues, because once actually the things happen, it triggers some other things to go along. So that's why we actually leverage one of the example, the framework in Python. It is the KOPF, okay? Today, I'm trying to introduce this, okay? For the executions, you can see, we PIP install the KOPF and the related dependency packages. And then we create the CRD, custom resource, okay, the data. And then we create the Python code where the triggers, the things happen and the events that happens, and then we want to do something else. So we want to program, right? As Python today, we are trying to build something. What happened after we create a resource? What happened, okay? And then something at the back is like a daemon running and then listens to what happened and then drive the whole things and calling the operators Python code to execute. Okay, that's what I'm trying to put this down, okay? And the execution at the end is you create the resource, and at the end, the background drop, the daemon is trying to execute all this extension and create here the people, venue, finding all the volunteers. Okay, you just create the events. You understand what I mean? So you create that, and all this extension will try to go over that. So what today, MySQL, we are trying to create, I want the MySQL to be deployed. And then what else we expect to happen? What else? We may want the resource from storage. We may want the resource to create as like the username password sequence. We may want some other things, the port, the deployments, and some others like the transparency middle tier where the connections can come in. And all this actually, for simplicity, I just want the MySQL to run. But at the back, some more things to happen. So this is what MySQL operator in here. As like, I am here, I do all the job at the back. But as Python, we create kind of all these activities and program to manage, okay, instead of the persons to do this. It's the programs to do this. So, as mentioned earlier, the CRD. As an example here, I'm trying to create a resource definitions where the name can be a web applications. Okay, I want to create a web. A web is what? A kind of pages, kind of the servers to deploy and run NGX, right? So what this actually we try to say, it is actually namespaces to be deployed somewhere. And it actually contain where we do actually retrieve the pages, okay, from GitHub, for example, from the Git. And as well as how many servers we want to have the load balancing, all this together. But for simplicity, I want the web app and my application in GitHub and then combine them to deploy. This is just very simple things here. But at the back, if I have the operators which listens to this and then create all this at the back, how this can be possible right here. So firstly, the CRD as YAML manifest, we just apply, and that CRD should be there, and just right after, we have this. But we have this and what? It's just the definitions, and then nothing happens because of the definition here. Nothing happened. So we want something to happen after this at the back. Someone look at this and check, and we create some other thing, create the server, create the storage, get the Git, and all this, combine them together, and then patches to the latest version, whatever. A lot of things can happen at the back, right? So what we do actually here is, just for example, we can deploy as the resource we did, okay, earlier, apply, And the CRD, we define the resource kind where the demo web, okay? Going back to slide here. If we look at this, we can actually see this. Demo web is the kind, okay? We define here. That's why in here, sorry, when we do this, we actually put this as the manifest, the kind as demo web, and we put the name as just ABC, right? It's just a name. And then we have two properties to set. One is the number of replicas, number of servers, okay? As the number of server, I just defined 2, meaning as the port. We deploy 2 port where Nginx, okay, will be executed. And as well as to get my GitHub, okay, where a static page or a PHP app, whatever, okay, is to be running. So what next is I have the CRDs running. I have this okay, the instance, the resource produce the instance, the objects to be executed. What else is the listener? And then at the back, it's trying to execute because of the CRD created. So what at the beginning is to import, okay, some sort of resources, okay, and the packages. And then if we look at this, okay, so KOPF is annotate with some sort of events on create. When we create the CRD, what happens? What happens? It means that there is the functions where we execute. This is the body of all this. Basically, what happens is at the back we deploy another kind of YAML manifest with the servers, with what the informations that we try to put the replicas and also to get the Git resources and put it and combine them together. And then make it run. So at the back here, we are trying to create a YAML doc. Okay, all this just YAML doc, a flat file, and then by passing the parameters with the required informations, and we deploy. And using the API and create a deployment for the replicas, which is the Nginx, and the image, which we define, what is the image? You can add extra and on its own, on your own preference, and tries to create your stuff. So here, just an example, we apply this, and then I'm here to share some sort of the demos in here. So you can see, we get the demo web is the resource. I create this as apply the CRD and the YAML with the kind of demo web, and then we have nothing, the port, because the operator is not running. Okay, so what I'm here is to run the operator as like a daemon, someone stand at the back, and then take up the role, look at what people are asking for, and then it execute and listen to the namespace where my demo, in here, the namespace called my demo. Oh, something happened, okay, the listener, is triggered on create. So when it is created, meaning the whole logic where the YAML doc is deployed, where the deployment of Nginx with 2 replicas, okay, now being executed. So you can see 2 ports as the deployment is running here. So easy. I did not actually create my own, but basically the operator, it does, right? So it is quite simple, okay? It's quite handy, easy. So what next is go back. We have kind of the overview of what happened. Okay, what is operator? Because we want to simplify the whole things by means of defining the CRD, and then by triggering all this event and the whole process at the back, we create all these fundamentals and all these foundations where the server, storage, execution, bind them together, back up all this process. Regarding to MySQL, it is more than just execute the MySQL and then run and that's it. No. MySQL has to be run for, quite for long. It has to be stable. When one is down, it has to be restarted. When one actually coming up, it has to rejoin. they may actually clone other data together. So all this happen in here. If we go back, hopefully, I'm trying to move around here. So here, this is the GitHub where you can find the related operator Python source, and also the related chart, YAML, deployment CLD. All this is here. The README is here. I'm not going over all this, but trying to explore what happens to this operator. So back to here. Look at this. As mentioned, there should be kind of controller. Listen to what happened, right? Listens to what happened. So when we look at this, we see there is actually the KOPF on create. There's also things happen. What happened when we try to delete the resource, remove the resource? What happened if there is something happen to specifically patching or modifying a specific field in the CLD? What happened? We change the version. What happened? Change version means we upgrade. It has to upgrade as like rolling upgrade. Stop one, putting some more images, or there should be something happen. Okay, upgrade is not simply to replace, maybe some extra. Okay, it has to be rolling up, rolling, shut it down, bring it back, or it has to be a process to remove, for example, the middle tier, or to disconnect, to migrate client applications from one connection to the other side, just for example. So there are things happen. We need to do the on event for field update, like the version, or actually it's the router version, or there is actually a CLD listener. There's also when something happened with the CLD, MySQL cluster are being created, the CLD. But the way is, it will generate kind of the YAML dot, where it generates the pod deployment. The pod deployment on create, on specific event, and as well as the deletions. Something happened, or even health checking. All this, they are actually in the controller. So when we create the CLD, what's inside is like prepare the init config, my.cnf or something from something else. And username, password, or things, prepare secret, and the middle tier router spec, as well as the whole InnoDB as cluster size, where it is not just one instance, but actually a cluster of multiple servers to build H8 cluster service, and the services where there are so many MySQL instances running, but we do not want IP1, IP2, IP3. We need a service to be attached to the application, and we just use the service. That's why we build service. So you can see there are so many things in here, stage 1, stage 2, prepare cluster service, and service account, role binding as the administrations, and prepare the cluster stable set, and what happens to the disruption, and there should be kind of the magic to make sure something happens that should adjust the size, minimum size of the cluster or something happen. So there should be the budget, disruption budget, prepare, and as well as the router servers, deployment, and how's the backup to be done. So all this actually built into here. So if we look at in here, there is here MySQL operator. There is kind of the things to look at this, and there's a controller where we can see in here the controller and the controller script. Okay, the controller script, you can see all these things here. The on create, and what happens with the on create, it tries to prepare all this, a long programming. Okay, what happens to the creations? So back on here. So as the MySQL operator, so let's look at a bit of the demo. So basically, if we look at this, So basically, if we look at this, we may have the namespace. Okay, we can try to create a namespace and deploy a Helm chart. Helm chart where I have some application deployed where we have my cluster in my IC namespace 01. What happens if I want to create another one? So in here, I try to put a script, and basically, it will try to connect to my repository because the image, which can be public, can be private. So I deploy my private repository for my Docker image where I need the Docker registry, okay, the username, password, or token, and then I install my cluster with the InnoDB cluster Helm chart and deploy onto my namespace with the corresponding properties where the values can be what? Like, for example, this is an example, okay, where I put in the username, password, what should be the default, my root, what should be the size of the database, can it be 50 gig, 1 terabyte? So I predefine some sort of information in here. Here, I try to define a 10 GB and tries to define a backup schedule and backing up for every 60 minutes, every hours, and actually I disable it. I don't want to run it regularly and wasting my space. So in here, I try to disable and then to back up to somewhere, and as well as we may define the use of like CPU resources. And as well as some other things, you may want the data from somewhere else, from some kind of the dump file, or actually from another existing running DB, where we clone the DB and into my CLD resources. So this is kind of the resources, and as well as to define like, okay, the time zone, or some other things we can actually define here. So what I can do here is I can run this and put it into another namespace for PyCon today, Hong Kong. So when I run this, basically it's trying to create a PyCon HK namespace and create the secret, and as well as to prepare the Helm chart and running this onto this PyCon namespace, okay? And after this, we will be able to see the port running. The port will be deployed with MySQL servers, okay? So this is actually calling this 3 node will be running. The 3 nodes meaning what? So basically, if we look at the CLD meaning, now I have InnoDB cluster. Get InnoDB cluster is another CLD, okay? And this CLD I'm running in the PyCon HK. So how this InnoDB cluster? We try to deploy 3 instances of servers and 1 set of the routers, which the middle tiers to connect to it. And it is still building in around 2 minutes time, and it will be there. So look at this, it's actually 42 seconds. So, and we look at here's the port. Basically, it's trying to, at the same time, running the initializations and building the servers and getting the image from the external and all this to build, okay, and maybe another 2 minutes, likely 2 minutes time, the server will be up and running and tie them together to form a cluster, Cluster means what? It means when I update the server on 1, the other 2, actually the data will be spread. And they will actually getting the data around this 3 server. 1 server is done. The switching over is automatic. And data is actually not just 1 place. It's actually 2 places, 3 places. It is reliable servers. Okay? As we see, the server is actually 3 servers. How can we connect to them? Connect A server, B server, or C server? We need a middle tier, the so-called the router servers. So if we look at this, now it is up and running. So if we look at that InnoDB cluster, what happens to this? Basically, it's trying to connect all this together. It's trying to connect all this together and waiting for another like few minutes. Oh, up and running. So the port was running 3 port and now 4 port. One is the middle tier. And as well as we get the service, and there should be the connections. How we connect to them. Like the interface to the server. It is here, the My Cluster interface. So what here is, I can execute this and then look at this. And let's say I have the My PyCon. I just create another connections to here. I run the MySQL client and connects to it. So what happens to this is I'm trying to bring up another client Linux image and then go over like the client application and connects to the server. It's connected to the server where I can connect to what should be the so-called service connect. So basically the username is root where I put in the ISO values, and then what should be the server? This is actually the service where we see this. The service is my cluster. Okay, we just reference by means of the name. Okay, it's like etcd, the name, and the port number we can actually define, and what happens to this? And I know the password, and I'm connecting to it. I can run this, and then show databases, and I can run Python. So here, Python, JavaScript, and all this actually we can connect to the server. And with the, like for example, I try to look at the status and look at the cluster. We can see it's actually running 3 servers, 3 ports, and they are actually on here. The first server, the my cluster 0, my cluster 1, and the my cluster 2, they are actually connected together. I can create database XXX, just an example, okay? And then create table, my table. So something wrong with my, oh, okay. So with this, I can basically, if I want to connect to maybe another server, like for example, right now what the server is the my cluster 1 or my cluster 2, I can connect to my cluster 1. Take this. Difficult to type. So here, we are connecting to the like NOC 2, and if we look at this, and we can see the data is here as well. So basically, we can we insert the data from my table, insert into my table? What happened? Errors. Because the cluster has 3 servers, but one of those in here, it is right. 2 of those, they are read-only, but it's actually scalable. You can actually read data, okay? You can connect and then read the instance data. And it is quite flexible for you, and we can actually use this, and we can change even like DBA get cluster, just an example. And here, if you look at the status, which one is the primary server? Is the number 1 server, the cluster 0. The cluster 0 is the read-write server as the primary. But we can do this to set the primary instance. Very difficult to do a copy and paste. I can copy and paste this, but yeah, how can I do this? Oh, better than nothing. My cluster 1. Yes, oh, no. Yes, and then what happens is here, I can see the primary switchovers. Anyhow, let's come back to here. So the operators, it is written in Python, and it is actually quite simple to apply because we have this simplicity by having these operators running, and you can deploy easily. And with the servers, which we use the stable set as stable, and the storage actually packed with the PVC, and the routers as the status and replica set. And there is also service to bind with the service to attach to one of those routers. And your applications can freely to connect to the My Cluster service. And here's just an example for using manifest. Deploy the CRD, apply the CRD, deploy the operators, and also the chart installations, where you add the repository and update, and then install your My Cluster, where you can create your own namespace if it is actually on the web, the GitHub versions. So here more on the operators. As you can see, get InnoDB cluster, you can watch for what is happening, and the services, what IP actually it is connecting to. And make sure one thing, storage. Storage. A server has the data putting on somewhere, the storage, somewhere. When we delete a node, we do not delete the storage because the storage is very important. It's your data, okay? So it's actually detached two pieces. One is the application, one is the data, the actual data. You delete the application doesn't mean you delete the data. You can run the same another kind of the versions for the application, for the server, and attach the same data. You just look at the data, physical storage. So if we truly to remove the server, make sure you remember to remove the PVC, the storage, because we do not want you to lose the data. So we do not want to delete the data by just one
advantage between Python and Golang for using operators, especially for MySQL's context.
Firstly, I would say that we have all this integrated with even Python or JavaScript, okay? We have natively kind of the package, all this up and running. So it is quite easy for us to run Python together with some other interface. Okay, if we build Go, there are only like SQL or something actually in between. There is no extension API to drive the extensions. So that's why Python might be good. Okay, and the language like KOPF, it is ready in the market, and people has been actually doing a lot. So it's just readiness. We understand people has been, because the first generation, look back a few years back, the operators. The very first version maybe just to Go, right? And thereafter, people also develop some other easy to use framework. Okay, we look at what kind of easy to use framework and what kind of the skill set in here and there. Okay, Go may be the first, but something can actually happen, catch up quickly. So I can't say we will change. Actually, we have the first generation in the past for the operator. Okay, that was written in Go. Okay, and then we change to use this Python. Okay, so this is like the version 2 already. Yeah, back to a few years back, the operator was written in Go, but that's all gone. So when we develop things or doing something, there are a lot of things constrained around us, right? Constraint, no matter this is resources, this is how you use, and also what we have at the back. So all this together, maybe we designed that this is the best for us, okay? And also for the people to work with what it is, because it's easy to use.
So any other question from the floor?
I think time is up, right?
Still have some time. Yeah. So any other questions?
Okay, so thanks a lot.
Okay. So thank you, Ivan. Okay. So before you guys go, actually, we are going to take a group photo. So if you don't mind, please stay on your seat for a few minutes, and then the track 2 people will come back in the same auditorium, and then we will do a group photo. Yeah.
Oh,
Thank you.
in here. Yeah. So everybody will come here.
Yeah. They'll come back here.
Yeah.